Hey guys, so welcome back to CE Box Tutorial channel, and this is our problem number 4 for the topic Flexural Strength under chapter 5 ng ating steel design. Ayan. So, determine the flexural strength of W357 by 101 of A242 steel subject to letter A, continuous lateral support, letter B, an unbraced length of 6 meters with CB is equivalent to 1.0, and an unbraced length of 9 meters with CB is equivalent to 1.0. And ito yung ating section, and given naman na lahat ng properties ng ating section. Okay? So, doon muna tayo sa letter A, continuous lateral support. Yes, kailangan pala natin munang i-check yung kanyang classification ng shape. Although, syempre, nakalagay na rito, compact shape. Alam na natin na maging compact to. Pero, syempre, masanay pa rin tayo na gamitin or i-check yung ating beam. Okay? So, dito tayo. So, 0.38 and 3.76 pa rin. So, check natin. So, 0.38 is square root of E over Fy. And yung sa ating 3.76 is square root of E over Fy. Yan. Okay, ang ating Fy is 345. So, 9.15. And then ito is 3.76. 90.53. Then, i-compare natin yung B over T natin. So, this is B over 2T. So, kalahati ng 255. So, 255 over 2. Then, divided by, T, which is 18.3. So, 6.97. 6.97. And then, yung ating H over TW. So, 357 minus 18.3 times 2, and then divided by 10.5. So, 30.51. So, lahat sila less than sa ating mga limits. Okay? Yung ating 6.7 less than dito. Yung ating 30.51 less than sa 90.53. Therefore, compact yung ating shape. Okay? So, siguro, itong solution na to is ilagay na natin dito sa baba. Pero sa board exam, hindi na masyadong chine-check pa yung yung kanyang width to thickness ratio. Kasi sa board exam, since na siya, rolled up section, halos lahat ang binibigay dun is compact section talaga siya. Or compact shape. Okay? So anyway, doon na tayo sa letter A. Continuous lateral support. So since continuous to, ibig sabihin ng ating LB is less than sa LP. Therefore, yung ating MN is equivalent to MP. So ang ating MP is Fy multiplied by Cx. So, meron na kagad tayo na nominal, strength or nominal bending strength under sa letter A. So, ang ating Fy is 345. Ang ating Zx is 1.88 times 10 raised to 6. So, divided by 1,000 squared para maging kilonewton meter. So, 648.6. Okay, so this is kilonewton meter. Okay. So, meron tayong dito? Nominal moment. Okay, so mamaya, mamaya kasi makalimutan ninyo, itong MP na to, yung MP na yan is yung ating nominal moment. So, yun yung gagamitin natin kapag gusto nating makuha yung ating design moment or allowable moment. Letter B, an unbraced length of 6 meters. So, yung ating LB is equivalent sa 6 meters. Tapos CB natin is equivalent sa 1.0. So, kailangan natin isolve yung LP and LR. So, doon muna tayo sa LP. Ang equation ng ating LP is ito. LP. Pero ba dito? Nasa equation ng LP natin? Ito. Ayan. So, 1.76 Ry multiplied by square root of E over Fy. So, LP is 1.76 Ry square root of E over Fy. So, saan natin makukuha yung Ry natin? Dun sa Iy. So, isolve na rin natin yung Rx and Ry. This is radius of gyration. Di ba ang radius of gyration is equivalent to I over A? So, square root of A over B. Ang ating A, mga moment of inertia. So, kung Rx, Ix na gamitin natin. So, 300.94 times 10 raised to 6. Ang B natin is area. So, 903.2. So, this is our Rx, 152.72. Okay. And then, yung ating Ry. So, okay tayo sa A. Ang A ang papalitan natin kasi gagawin natin siyang Iy. So, 50.36 times 10 raised to 6. Okay, so palitan natin yung letter A. So, A natin is 50.36 times 10 raised to 6. And then, yung B natin is yung area naman ng di ba? Ng beam. So, wala tayong problema dyan. So, 62.47. So, ito yung ating Ry. So, makukuha na natin yung ating LP. So, 1.76 multiplied by Ry na 62.47 multiplied by square root of E over Fy, which is 345. So, 26. Okay, so millimeters to So, divide natin ng 1,000 para maging meters. So, 2.65 meters. Yeah. So, solve na natin yung LR natin para sigurado tayo. Ayan. So, ang LR natin is mahaba-haba. So, I think screenshot natin to. Ayan. Okay, so LR natin is 1.95 RTS multiplied by E over 0.7 of Fy multiplied by the square root of JC over SX H sub O multiplied by square root of 1 plus square root of 1 plus ang haba pala, no? 1.676 multiplied by 0.7 of Fy over E multiplied by Sx multiplied by H sub O over J multiplied by C. And this is squared. Yan. Okay. So, check natin kung ano yung mga given. Meron ba tayong RTS? Wala. Okay. Meron tayong E, Fy, meron tayong J, meron tayong, okay, susunod natin yung C, meron tayong SX, kasi makukuha natin yung sa IX. H sub O, meron tayo. Okay, so yun lang mga kailangan natin. So, solve natin yung SX. SX natin is equivalent sa IX over C. Yung ating C is ito ito yung tinutukoy ko na C. Yan. Sabi natin C1. Kasi iba pa tong na to, C na to. Okay? So, 300.94 times 10 raised to 6 over yung C, kalahati ng 357. So, this is 1.69 times 10 raised to 6 millimeter cube. Okay. Then, check natin yung code. Yung C na tinutukoy doon is ito. Ayan. So, ito, for channel, ito yung equation natin. Pero, syempre, double symmetric I-shape tayo. Yung ating C is 1.0 na. Then, meron tayong equation ng RTS doon. Ang equation ng RTS natin is okay, RTS squared. Square root of IY, CW. IY, CW over SX. So, meron tayong SX, meron tayong IY, meron tayong CW. So, masolve natin tong RTS squared. Double ko nga. Double check natin. Okay, RTS. So, square root of IY, 50. Okay, 50.36. Sorry, medyo nag-ano yung mouse. Yan. Medyo nag-loko yung mouse natin. Okay. Ayan. Okay. Sana tayo. IY 0.36 times 6. Okay. Multiply by CW 1.44 times 10 raised to 12 over yan. Over SX. Ang SX natin is 1.69 times 10 raised to 6. So 50 38.92. So 50 38 0.92. Okay. This is millimeter squared. Yan. So, kung gusto natin kunin yung RTS natin, square root lang natin yan. So, 70.99 millimeters. Yan. Then, okay. So, solve na rin natin itong JC over SX HO. Tapos, i-store natin siya sa A. So, ang J natin is 1.25 times 10 raised to 6. Ang ating C is 1 over SX, 1.69 times 10 raised to 6. Multiplied by H sub O, 337.3. Yan. So, 2.19 times 10 raised to negative 3. And store natin siya sa A. Okay na ba tayo lahat? So, check natin. Okay. So, okay na lahat. So, 1.95 RTS 70.99. And then, E is 200 times 10 raised to 3 over FY over 0.70 of FY 345. Multiplied by square root of yung ating A. Okay, multiplied by square root of 1 plus square root of 1 plus 7.76 multiplied by ano yun? Okay, 0.70 of FY over 200 megapascal multiplied by okay, kabaliktaran na to, no? So, reciprocal lang siya. So, 1 over A tayo. 1 over A. Then, squared. Yan. And then, divide natin ng 1,000. Para maging, para maging meters. Okay, so 7.6 meters tayo dito. So, ang LR natin is Ang LR, or dito na lang siguro, ang LR natin is 7.6 meters. So, shade natin lahat. Lahat ng mga kailangan, LP, saka LR. Ayan. So, ngayon, ang ating LB na 6 meters is greater than sa LP, but less than naman sa ating LR. Okay, so therefore, yung ating equation is pasok dito. Ayan. Okay, so, screenshot ulit natin. Kasi hindi ko masyadong ma-memorize. And remember, dito lang tayo kasi pasok tayo sa sa compact. Anyway, kapag non-compact naman at dito tayo pumasok tayo dito, ito pa rin naman yung gagamitin. Parehas lang naman sila. So, yung ating MN is equivalent to CB multiplied by MP minus 0.7 of FY SX. Actually, itong na to, itong FYSX na to is MY, hindi ba? Na-observe nyo ba? This is yield moment, yung FYSX. So sabihin, pwede natin i-rewrite na MP minus 0.7 of the yield moment. Ang nangyari kasi doon, ba't naging ganyan? Yung ating kasing FY, binawasan natin ng 30%. Okay, ginawa lang natin siya 70%. Okay? Ayan, so okay, multiplied by LB minus LP over LR minus LP. And syempre, dapat less than tayo or equal sa MP. Remember, hindi tayo pwedeng lumagpas sa MP kasi yun yung pinakasagad bago mag-fail yung ating member, hindi ba? So, hanggang dyan lang tayo sa MP. Hindi tayo pwedeng lumagpas dyan. So, solve natin. Meron naman tayong kompletong mga value sa lahat ng mga notations dito. CB natin is 1.0. Ang MP natin is 648.6. And dapat convert natin to into Newton millimeter. Okay, so times 10 raised to 6. Minus MP 648.6 times 10 raised to 6. Minus 0.7 of FY 345 multiplied by SX 1.69 times 10 raised to 6. Hindi tayo, no? Okay, yung buo na to, no? Check natin yung natin. Ayan, then, saka natin, check natin to, ha? Medyo nalito ako. Sige, dito muna tayo sa una. So, MP, 648.6 times 6 raised to 6 minus 0.7 of 345 times SX, 1.69 times 10 raised to 6. Yan. Then, multiply natin ng LB. Ang LB natin is 6 minus LP, 2.65 minus, over LR, 7.6 minus LP, 2.65. Yan. And then, ito, start natin sa B. Saka natin i-minus yung B sa MP. So, 648.6 times 10 raised to 6 minus B. And then, multiplied by 1.0, CB. Okay, so divide natin ng 1,000 squared para maging kilonewton meter. So, 485.86. Kilonewton meter. So, less than tayo sa MP. So, okay tayo dyan. So, nakuha na natin yung ating nominal moment under sa condition letter B. Last. Ayan. So, 9 meters naman ang ating LB dito. Meters. So, since ang ating LB is greater than sa ating LR na 7.6, ito yung gagamitin natin. Ayan. Yung ating MN is equivalent sa FCR-SX or critical buckling stress. So, MN is equivalent sa FCR-SX and this should be less than or equivalent sa MP. So, equation for FCR is equivalent to CB pi squared E over, okay, LB over RTS squared multiplied by square root of plus 1 plus 0.078 multiplied by JC over SX H sub O multiplied by LB over R sub TS squared. Ayan. Okay, so check natin kung dyan pa rin yung value ng ating JC over SX HO. So alpha A yata yun. Okay, so 2.192. Okay. So since dalawa yung ating LB over RTS, i-store na lang din natin yan. So i-store na lang natin siguro siya sa ating sa B. Okay? Yan. So i-store natin to sa ating alpha B. So ang ating LB is 9 meters. So 9,000 over RTS. Ang ating RTS is okay, 70.99. Yan. Then, naka-square na sila, no? Para naman sila naka-square ata. Okay. Oops. Ayan. So, alpha B. So, naka-store na yan. Okay, so solve mo natin yung ating FCR kasi lahat naman na given. Meron rin tayong CB. Ang ating CB is 1.0 multiplied by pi squared E, so 200,000 over LB over RTS square, which is our alpha B, multiplied by the square root of 1 plus 0.078 multiplied by JC over SXHO, that's alpha A, multiplied by LB over RTS squared, which is our alpha B. Ayan, so 237.795. So 237.795. Okay, so this is FCR, so critical backlink stress. So, megapascal stress siya. Ayan. So, makukuha na natin ngayon yung ating MN or yung ating nominal moment under sa condition letter C. So, yung ating nominal moment is equivalent to 237.795 multiplied by SX. Ang ating SX ngayon is 1.69. Okay? So, multiplied by 1.69 times 10 raised to 6. So, makukuha natin na MN dito is Newton millimeter. Tama ba? So, divide natin ang dalawang 1,000 kaya magiging 1,000 squared. So, 401.874. So, 401.78. Okay, 874. Kilo Newton meter. Ngayon, depende na lang sa ating problem kung ang ipapakuha niya is design moment or design moment strength or allowable moment strength. Remember na kapag lang naman sa LRFD, ang imumultiply natin na reduction factor or resistance reduction factor sa LRFD is 0.90. And kapag naman allowable, i-divide natin yung ating nominal moment sa ating omega. Okay? So, under sa ating flexural strength, ang ating omega under ASD is equivalent sa 1.67. Okay? So, yan. Ito lang kasimple yung ating problem number 4. So, wala naman siyang masyadong pinagbago sa ating problem number 3. Ang pinagkaiba lang is nagkaroon tayo ng different conditions sa kanyang unbraced length. So, nagbigay lang yung ating problem number 4 ng different unbraced length. So, sa letter A, continuous lateral support. Sa letter B, 6 meters, which is pumasok sa sa limits natin na kung saan greater than siya sa LP but less than LR. Kaya iba yung naging equation ng ating MN. Okay? So remember that when our unbraced length is less than sa ating LP, yung ating nominal moment is equivalent to our plastic moment. Pero yun nga, kapag ito pasok siya sa limit natin, kagaya ng tutong condition na to, yung ating MN is ito. Okay? And then, kapag nag-greater than yung ating unbraced length sa ating upper limit na LR, ang ating equation for MN is magiging FCR SX na. So, ibig sabihin kung FCR na yan, critical backlink stress na siya. Then, multiply lang natin siya sa ating elastic section modulus. Then, makukuha na natin yung MN once na makuha mo yung ating critical buckling stress. Okay, so ganun lang siya kasimple. Okay, so this is our problem number 4. So thank you for watching. Bye!